don't think you are. All right, let's get this done. So today is the third, and we're still doing parabolas. What
Boxes.
what changes today is we're going to be given different types of information, and we're going to be working with some more awkwardy sort of um, directrix focus values. Our vertices should still be whole numbers. So just bear that in mind as you work through this. If you go through a problem and get a vertex of like -2, 15, 31sts, something I think has gone wrong. Because I mean, is it possible? Sure. But from what I understand right now about this, like what I'm seeing from these, I don't think you're going to face that. So you can kind of hold on to that. Vertex should be pretty. Okay. Focus and directrix are going to be whatever they want. So anyways, for my first example, let's just take a look at given the focus at -3, 4 and the vertex at -3, 7. Let me ask you this kind of a big brain question. When I give you focus and vertex, or when you find focus and vertex, will they always share one coordinate?
Yes.
They have to, right? So like if they're vertically aligned, they share the same X coordinate. If they're horizontally aligned, they have to share the same Y coordinate, right? So we already know from this that it's going to be a vertically aligned parabola because their X's are the same, right? So the question becomes, what's P? Like, honestly, at no point do you ever you don't need the directrix to write an equation. So like, I think the good thing for me here, I said this the other day, what keeps me sane is just making sketches. So -3, 4 is, just, and again, this is just sandbox. This doesn't have to be perfect, but maybe it's like right about here. And then -3, 7 is right about here, right? And so I'll just always remember the key here is to remember that the focus is inside the parabola, right? And so since the vertex is the high one up here, then this yellow one has to be the focus. Okay. So maybe for the sake of this lesson for the next few minutes, I'll just try to be consistent. Red will be the vertex and yellow will be the focus, right? So if someone asked me for the directrix, like if your math teacher on a quiz said, what's the equation of the directrix? Could you find it?
Yeah.
Of course you could. It's the same distance above the vertex as the focus is below. So how far below the vertex is the focus? 3. You can just tell that by comparing the y coordinates. So if I did say what's the equation of the directrix, then you know that it's up here somewhere, right? And that it's got to be y equals 3 above 7, which is 10. But again, for writing an equation, that has no bearing. So maybe that's just bonus information, right? So what we did come here for is the p-value because we already have our vertex and that's awesome. So like we could start writing the equation. We would just be missing the 4p part. What is p in this case? Right there. What's that distance? It's 3. So we're going to say p equals -3, right? And again, unlike the delta math, I'm not a big believer in this stuff about just calling it a positive number. Let's call it what it is right away. Okay. Negative because it's down. So which flavor, or maybe that's the wrong question. How are we going to start the writing of our equation? The only things on the board now that matter, since I'm recording this, I can erase virtually everything. Yep. So the only things left on the board are the only things that matter now, right? We needed some other stuff like the focus to get there, but we don't need it anymore. So go ahead, sir. Sorry, I did you again. Bless you. Right. So tell me what that's going to look like for us.
So x plus 3, right?
Nice.
Equals 4 times 3, so -12.
Nice.
And y and 7.
That's it. I mean, if you were to look at this lesson or something like this a week ago from the outside, you'd think, what's going on? But you realize once you get in here, it's just not that bad once you can get your head around where's my vertex? What's my P? But to me at least, it starts with a picture. Gotta have that picture, man. And then just because I learned that way doesn't mean you do. But I find the pictures to be really nice. So let's do another one, and then we'll get to the ones with fractions. So the other possible combination, if we're talking about 3 things, So if there's three people in a room and you pull them out two at a time, that can be done three different ways, right? You can pull A and B, B and C, or A and C. So like we've done focus directrix, we've done focus vertex. That leaves the combination of what do we do if I give you the vertex and the directrix? As always, it's going to come down to, at least for me, a visual sort of thing. So let's say that the vertex is at 2, -1. And let's say that the directrix is the line x equals 10. Thank you. So just a sketch would be fine. So when I found today as I like to do more of these kind of like before you guys get here. So I've been focusing on um, making my axes not have a ton of wasted real estate. Like I know that the directrix being a vertical line at 10 means I should leave lots of room over to the east, right? So I'm going to go to 10 and graph a directrix like this. Okay. And again, I'm not grading your artwork here, but if you want to label it as 10, great. And then the vertex is at 2, -1. So that's going to be probably right about here. Something like that. So what I found interesting as I was kind of conjuring up this example earlier was the conversation I wanted to have with you is where's the focus? To the left or to the right of the red dot? Like it's easy to want to say to the right because it feels convenient, right? But what you have to remember is that the parabola opens and swallows the focus. Yeah. And so that's where I thought this might be an interesting problem is that if the red is the vertex, the focus has to be somewhere. So the beast forms, like this. And the focus is going to be in the belly of the beast somewhere. So visualization again to me is the key. So however far apart these are, I just kind of estimate that, and then I can get my head around what that is. So that's where the focus is right there. Why do I need the focus? I don't explicitly need the focus for the equation, but what do I need them for? The p-value, right? So the focus is going to be right here. And if I asked you for its coordinates, if I said name the focus, then you would care. You'd have a reason to write this down. What is it? It's -6, -1, right? Because you went 8 units from the directrix to the vertex, and then another 8 units from the vertex to the focus. See?
I would say for an equation like this, we'll be not even really need the focus because we could just see how far the x coordinate of the vertex is.
Yes, and again, you're all very smart people, and so you're gonna find shorter ways probably to do this. For me, it's just I like the picture. It reminds me that my p is negative. It reminds me not to fall for the trap of thinking that the focus is just gonna logically be in between there, stuff like that. But no, you're totally right. Like there's ways to save time. So yeah, we figure out that since this distance is 8, like Zach said, then we know that this distance is 8. So what is our p value? Remember, P goes from vertex to focus. What is it? It is -8. Very good. And again, once I kind of get over that kind of hurdle at the beginning, then I could take everything and say, I don't need any of you anymore. I got what I came for, the p-value. So what would my equation look like?
Be the lefty righty one.
The lefty righty one. So what's it going to start with?
1.
So give me some numbers with that.
Y squared
Equals.
-33 times x -3.
Just like that. So that was sort of the little comfy zone warm up. So just to kind of get us out of our comfy zone, we're going to now do a few examples that just have some fractions. But the computer generates most of these. I messed with a couple of them earlier before you got here, but by and large, I just kind of let the computer do these. So again, the computer is going to have awkward directrix values and it's going to have awkward focus values. But rest assured, your vertex is going to be at like 4, -2 or 1, 3 or something pretty like that. Okay. So let's take a look at some fractions real quick. So let's say we do one where the vertex is at the point -4, 2, and the directrix is the line x equals -47/12. It's easy to panic a little bit, but when you see how this all flows together, you'll see that there is a method to the madness. There's a rhythm in there. So I'm gonna draw a picture. If you don't like drawing pictures with me, I that's your thing. I'm gonna draw a picture. So I'm gonna focus on where the vertex is, and the vertex is up in quadrant 2. So that's gonna be what I kind of focus on. So my vertex, bless you, is gonna be at left 4 up 2. So maybe right about here. Okay. So this is 2, and this is -4. And that directrix can be scary, but it's just not, right? So we're all in an upper level enough math state that, we've been doing this long enough that we understand what -47/12 is. Yeah, -47/12 is trying to be this. It wants to be -48/12 because what is that equal? That's -4.
Yeah.
So it's like, cool. But he's not quite there. So what I have to think about here is relativity. Like, is -47/12 going to be to the right of the red dot or to the left? To the right, because -47/12 is a little bit shy of making it all the way to -4. So what I'm going for here is not artistic perfection, but rather just an understanding that the directrix lies to the right of that vertex, right? That's the key. And at this point, I feel like the artwork has just about served its purpose. Again, to Zach's point, do I explicitly need to tell anyone what the focus is? No. Will there come a day when I ask that of you? Yeah. There's going to come like a quiz day where I say, name the vertex, name the focus, name the directrix. Like, you're going to give me all the skeletal pieces and then write the equation. So for us, we understand that if that's the vertex, that the focus gets gobbled up in the belly right about here. The key for us then is to be able to just understand how this works. How far away was the directrix from the red dot? 1/12. And since it's opening clearly to the left, then we can say that our p-value is equal to -1/12. Kind of hard to not buy that, I think, right? That's a fact. And again, we got what we came for. Picture, no picture. Some of us need it more than others. I know I do. If I sat down and did like 30 of these in a row, I'd probably stop doing pictures just because the pattern would start to set in. But for me, man, I need to see what I'm doing. So on the board now, I have everything I need. I can erase everything. Please don't ever do this because like I want to see what you do. But like for me, I'm saying that's all I need. So what kind of equation am I going to do?
Lefty righty.
Lefty righty. So I'm going to have y minus 2 squared equals what? You didn't know you were showing up for a basic 6th grade fraction test today. What is my 4p going to equal? -1/3.
Yeah.
And then what's going in here?
X.
Good. And for anyone who doesn't want to ask because you feel like, boy, people are going to make fun of me, just always remember that 4 times the fraction means 4/1 times the fraction, right? So, I mean, that's not the only way to explain that, but it's a nice simple one. So, any questions about that example? Okay, let's do another. I'll try to get these last ones done before you got to go. You got
I wasn't trying to think.
No, you're not. But today's a hockey day. All right, so I got about 7 minutes. So let's do one where the vertex, yeah, 6 or 7, right? The vertex is at -1, 1, and the focus. So here we go again. We're kind of going off the norm here. The focus is going to be at the point -19/20 and 1. So as I get ready to make my graph, which I will destroy eventually, I'm clearly wanting to focus just on quadrant 2. Don't need all that extra graphy space when all the action's happening right there. So I'm gonna first start by graphing. I'm gonna go to -1 and then up to like 1. So I'm gonna put my vertex here, and I'll make my vertex red. I'm trying to be consistent with this. And as always, the question is, relative to him, where is the focus?
Right.
It's going to be to the right because the y value stays the same, but the x value is bigger. It's like a smaller negative number, but it's technically bigger, right? So -19/20 is going to be right about here. And this would be a good time for me to put a little parenthetical comment like figure not drawn to scale, but that's good enough. Do I care where the directrix is? I mean, sure, it's on the left, right? What is the equation of the directrix just for shiggles? It's over here somewhere, right? What would it be?
21.
So x would equal -21/20, right? So we know that that would be the equation of the directrix when the time comes that someone wants to know. What's p?
120.
It's 1/20th and it's facing to the right, so we keep it as a positive. And again, all of that work was for a purpose, and that is to be able to get that. That's all that matters now. Okay, and since it opens to the lefty righty, we're going to pick the one that starts with y squared. And so we're just going to hop right in. You should be pretty good at this after the delta we've been doing. So we're going to have y minus 1 squared equals what?
1/5.
Good job. That's how we do it. 1/5 of what?
X plus 1.
Nice. And by the way, if you see it in the directions, which I think, yes, you will see it in the directions. This format that we're using, I figure it's time I tell you this, is called transformational form. Um, so when you see that, conics come in a lot of different forms. There's like standard form, general form, transformational form. So I just didn't want you to think that was like something weird. That's the one that we're working with right now.
Are all forms like interchangeable?
Yeah, I mean it's like when we did algebra 2 with like vertex form and standard form, like they all represent the same thing. You could turn any one into any other. But yeah, this one particular is called transformational. So let's do one more so I can get this done and you guys can have some time to work. So for our last example, we're going to do the focus. I tweaked this problem quite a bit. I hope I didn't mess it up. So our focus is going to be at the point 2, 223.56. Sorry. And our directrix is the line y equals 225.56. The key to not being intimidated or bothered by this problem is to just get in there and say, you know what, I'm not going to play these games with you. Clearly, those two numbers are flirting with something, right? And if you're good at mental math, you already know what that is. What's 223 or 225/56? What are they hovering around?
That's 4.
It's 4. Listen, straight up, if you take this bottom number, 56, and you multiply it by 4, you get 224. It's not coincidence that the numbers, the focus, and the directrix so have that sandwich, right? They're like, we got you surrounded, sucker. So clearly we're tending towards a y value of 4. So don't be intimidated. No matter how ugly the fractions get, your job is just to kind of say, what am I tending towards? What are they trying to tell me with this? So let's get eyes on it, and then we'll see that it's really not that bad. None of these are as bad as they would have looked to you, say, a few days ago. So I want to focus on quadrant number 1. So my um, scaling, like what do I want someone to be able to see is I want them to be able to see 1 and 2, and then I want 1, 2, 3, and 4. So there's some basic math would lead us to the conclusion that that's where we want to get eyes. Almost there. You have like one more minute, or do you just want to watch it later?
No, I think I get it pretty good. Isn't P -156?
Uh, believe so. Yes. Mhm.
Awesome.
That's awesome. Thank you. There it was. Awesome. Thank you. Let's take a look at the directrix. And so I'm going to go again, figure not drawn to scale, FYI. I'm going to go a little bit above 4 and draw my directrix. Clearly way out of scale, right? And then I'm going to go a little bit below that and I'm going to draw my focus, which is right down here. So halfway in between there has to be the vertex, right? And that's what I was talking about is like these things don't just, we're not here to get you. We're not here to throw claws at you. Like halfway between 223 and 225 is 224. 224 divided by 56 is 4. So we can understand from this that the vertex is going to be at 2, 4. And the only thing missing, and Andy threw this out before he went hockey bailing, is what's P? Well, if the vertex is in here, well, you can see how crooked that is when I zoom in on it. Holy buckets. So if the vertex is right there, then the P value goes downwards. And how far is it?
6.
Yes. So these have a distance between them, a distance of 1/56th of a unit.
Yeah.
And since it's going downhill, then our P value is negative 1/56th. It again, to someone walking in not knowing what we're doing, this would look so abstract and difficult, but it's just really basic math at the end of the day. So I'm going to zoom back out and we're going to go figure out our equation. So since it opens downwards, we're going to pick the x squared value or the x squared flavor. What's it going to start with?
Up and down.
Nice. Grabbing this equals what? Love it. Love that basic math. Negative 1/14th of
Y minus.
yeah. And again, should be looking at that and saying, yeah, that looks really hard, but I'm in it. I'm here for this. Like I'm not, it's not bad. You guys got this? So I don't know where you are in your learning right now, but I'm going to hand out assignment 32, which is some practice with these. There's most of them on there have fractional values. So make your sketches and get comfy with understanding where things lie relative to each other. That's the key. And you won't need pictures forever. I'll keep the recording paused in case anyone has a question.